no problem. Okay, so just wait. So I think so. In last class, we have to solve one problem based on uh, solution of discrete time system. So from the formula, the solution of discrete time state variable. I am audible to you
Yes, sir.
and screen is visible to you.
Yes, sir.
Yeah, okay. So the solution of state variable, discrete time state variable, that is inverse Z transform of Z I minus G to the power minus 1 into G into X0 plus inverse Z transform of X I minus G inverse into H into UZ. And Z I minus G to the power minus 1 into Z is known as state transition matrix of discrete system. So in last class, I have solved one problem. Suppose a state variable, discrete state space equation, that is xk plus 1 is equal to g xk plus h uk, yk is equal to c xk. There is no part of d into uk. So that means D matrix is equal to 0. And the value of G matrix is equal to 0, 1 minus 0.16 minus 1, and H matrix is equal to 1, 1. And the initial value of the state variable is equal to x1, x1 0 and x2 0 is equal to 1 and minus 1. Then find out the state transition matrix and the solution of the given state variable. Okay. So in the last class, I have solved that is the solution of state transition matrix, that is the inverse Z transform of Z I minus G inverse into Z. So in this way we have to find out the inverse of Z I minus G. So and then finally the state transition matrix is equal to just wait. State transition matrix is equal to 4 by 3 minus 0.2 to the power k minus 1 by 3 minus 0.8 k, and second element 5 by 3 minus 0.2 k minus 5 by 3 0.8 k. In this way we have to find out the solution of state transition matrix. Okay, any doubt up to that? Any doubt?
No, sir. No, sir.
No. Now we have to find out the solution of the state variable. So from the definition, solution of a state variable, that is xk is equal to inverse Z transform of Z I minus Z I minus G inverse into Z into x0. Okay, plus Z inverse of Z I minus G inverse into H into UZ. Yes or no? Yes or no?
Yes, sir.
Okay. So there is a two part. First part due to initial value and second part due to applied input. So first part, that is equal to Z inverse of inverse Z transform of Z I minus 1 Z I minus G inverse into Z into X naught. Okay, first part. Okay, so from the previous solution, so that is the inverse Z transform of Z I minus G minus 1 into Z is equal to 4 by 3 minus 0.2 k minus 1 by 3 minus 0.8 k, comma, next element 5 by 3 minus 0.2 k minus 5 by 3 minus 0.8 k, and third element minus 0.8 by 3 minus 0.2 k plus 0.8 by 3 minus 0.8 k, and fourth element minus 1 by 3 minus 0.1 k plus 4 by 3 minus 0.8 k. Now we have to multiply with the initial value. So initial value of the state variable, that is equal to 1 into minus 1. Okay. So 1 into minus 1, that means 1 into minus 1. So first element becomes 4 by 3 minus 0.2 k minus 1 by 3 minus 0.8 k minus 5 by 3 minus 0.2 k minus 5 by 3 minus 0.8 k. Okay, and second element, again you have to multiply this with the uh, initial value of state variable. So minus 0.3 minus 0.2 k plus 0.8 by 3 minus 0.8 k minus 1 by 3 minus 0.2 k plus 4 by 3 minus 0.8 k. Okay, any doubt? Any doubt?
No, sir.
So we have a two factor 0.2 to the power k minus 0.2 to the power k. 4 by 3 plus 5 by 3 is equal to 9 by 3. 9 by 3 means 3. That means is equal to 3 minus 0.2 k and minus 1 by 3 and minus plus 5 by 3, that is equal to 4 by 3. So plus 4 by 3 minus 0.8 k. Okay, now minus 0.8 by 3 and minus plus 1 by 3. Yes or no? So finally minus 0.8 plus 1, that means is equal to 0.2 by 3 minus 0.2 k and 0.8 by 3 minus 4 by 3, that is equal to minus 3.2 by 3 into minus 0.8 k. Any doubt? Any doubt?
No, sir.
Okay. Now we have to find out the second part. So the second part is equal to inverse Z transform of Zi minus G inverse into H into Uz. Yes or no? Yes or no? Hello.
Yes, sir.
So what is the value of Zi minus G inverse? So Zi minus G inverse is equal to, I think, and what is the value of H matrix? H matrix is equal to 1 1, and suppose the input is equal to, input matrix is a step input. Okay. Hello. Suppose input is a step matrix. Hello.
Yes, sir.
So what is the Z transform of U K, that is equal to 1 by Z by Z minus 1?
Mm.
Yes or no?
Yes, sir.
Okay. So that is Z by Z minus 1 into Z I minus G inverse. Okay. So it becomes Z I minus G inverse into Z by Z minus 1 by second element is Z by Z minus 1. Any doubt? And you know Z I minus G inverse is equal to Z I minus G inverse is equal to Z I minus G inverse is equal to Z plus 1 Z plus 1 by Z plus 0.2 into Z plus 0.8, and second element 1 by 1 by Z plus 0.2 into Z plus 0.8, third element minus minus 0.16 by Z into Z plus 0.2 into Z plus 0.8. Okay, and the fourth element Z by Z plus 0.2 into Z plus 0.8 into Z by Z plus Z minus 1 and Z by Z minus 1. Now we have to multiply this factor, so it becomes inverse Z transform of Zi, inverse Z transform of Zi minus G inverse into H into H into Uz is equal to inverse Z transform of, if you multiply with this term, then it becomes Z into Z plus 1 divided by Z plus 0.2 into Z plus 0.8 into Z minus 1. Yes or no? And next element again plus uh, plus uh, plus plus Z into Z plus 0.2, Z plus 0.8 and Z minus 1. Yes or no? So next element minus 0.16 into Z divided by Z plus 0.2, Z plus 0.8 into Z minus 1. Next element plus Z square by Z plus 0.2, Z plus 0.8 and Z to the power minus 1. Yes or no? Now again we have to find out the inverse Z transform of the given function. Hello, I am audible to you?
Yes, sir.
So if you solve this and finally now we have to find out the inverse Z transform of the given function. Okay. So now we have a two factor, a first factor and second factor. So if you if you use the partial fraction method, using the partial fraction method, you can find out the inverse jet transform of the two function. So now, and if you combine with the first term, then xk become. So please solve it in your copy. Please solve it. So xk have two part, that is inverse jet transform of zi minus g inverse into z into x0 plus inverse jet transform of zi minus g inverse into h into uz. Okay. So we have two part. First part is due to initial value and second part is due to applied input voltage. So if you solve this expression, you can obtain the solution of the second part, and you have already solved the first part. So if you combine the solution of first part plus the second part, then the output equation is equal to minus 17.6 minus 0.2 k plus 22 by 9 minus 0.8 k plus 25 by 18, and second element C.4 by 6 minus 0.2 k minus 17.6 by 9 minus 0.8 k plus 7 by 18. Any doubt? So we have a two state variable x1k and x2k. Any doubt in the solution of discrete state variable equation? Any doubt?
No, sir.
Okay. Now our next topic.
No, sir, H of sir H of UZ sir थोड़ा दिखाएं सर इसके previous page में H of UZ H into
H,
UZ sir
so H is equal to 1 1. H is
yes
equal
sir.
to 1 1, and UZ is the jet transform of applied input. So we have applied input is equal to step input, and you know the jet transform of step input is equal to z by z minus 1. So just we have multiplication of matrix. It is just a multiplication of matrix. Okay. So you have already we have already solved this type of problem in a continuous time domain. Okay. So okay, now how can you obtain the transfer function? Suppose a very important formula, how to obtain first transfer function. Next topic is how to obtain first transfer function from discrete state space equation, that is SS to TS. SS to TF means you know the state space equation, that is you know in a discrete time the state space equation is equal to x k plus 1 is equal to g x k plus h u k, and output equation is equal to cxk plus duk. Okay. So now we have to find out the pulse transfer function of the given discrete system. Okay, how can you find out? If you correlate with the continuous time domain, you correlate with the in the continuous time domain, suppose a state space equation is equal to x dot is equal to ax plus bu and y is equal to cx plus du. So then in this case transfer function of the system gs is equal to, what is the formula of transfer function?
The Laplace of output by Laplace of input.
No. From state space equation to transfer function conversion. So
Si
you
minus A.
yes, tell me.
Si minus A. Sir,
No,
BU by SI minus.
no. Very important formula in continuous time domain. जल्दी बताओ.
Sir, inverse हो जाएगा सर. SI minus A inverse.
Very important formula even for the important for the GATE examination. GATE examination में इस तरह का प्रॉब्लम रहेगा कि ए बी सी डी मैट्रिक्स दिया हुआ है, फाइंड द ट्रांसफर फंक्शन ऑफ द सिस्टम. एक सिंगल लाइन का फॉर्मूला है, हम ऑलरेडी बता चुके हैं. C into SI minus A inverse into B plus D. What is C? C is C matrix. A state transition state matrix. B input matrix. D is the input output related matrix. That is ये फॉर्मूला बताया, yes or no?
Yes, sir.
Okay. So similarly, we have to find out the pulse transfer function from given state space equation. Okay, that means initially you know the state space equation of discrete time system, that is xk plus 1 is equal to gxk plus huk and yk is equal to cxk plus duk, and g, h, c and d matrices are given to you. Now we have to find out the pulse transfer function. In the previous class, I told you that is you know the pulse transfer function and how can you represent the pulse transfer function to the state space equation. So this part is known as transfer function to state space conversion. So in the last class I told you there is a 4 method: canonical, observable method, canonical, diagonal method. There is a 4 method. How can you represent any pulse transfer function to state space equation? Okay, now you know the state space equation of discrete system, that is you know the GHCD matrix. Now we have to find out the pulse transfer function of the given system. Okay, hello. So derivation of the pulse transfer function from the given state equation, now we have to apply. So you know, suppose you know the xk discrete time system g xk plus duk, sorry g no h, sorry h matrix, okay, and yk is equal to cxk plus duk. Okay, now apply Z transform. So it becomes Z into xz minus Z into x0 is equal to g x z plus d uz. Okay, and output equation becomes yz is equal to c xz plus d uz. So if you rearrange state equation, then xz becomes zi minus g inverse into h into uz. uz. Why you have to ignore this part? Why you have taken this part as a 0? Hello, I am audible to you?
Yes, sir. Sir, transfer function में sir initial condition को 0.
Yes, because if you want to find out the transfer function, so in the transfer function we have to consider that initial value of the system is equal to 0. That's why we have to ignore this part, or you have to take it as a 0. Then xz is equal to zi minus g inverse into h into uz. Now we have to put this value in the output equation. So output equation is equal to c into if you put the value of c into zi minus g inverse into h into uz plus d into uz. Okay, if you take common uz, then it becomes c into zi minus g inverse into h plus d into uz, and you know the first transfer function, that is the first transfer function is equal to yz by uz. Now it is equal to c into zi minus g inverse into h plus d. Any doubt? Any doubt?
No, sir.
If you compare with the continuous time domain, they are almost same. In continuous time domain, transfer function is equal to c into si minus a inverse into b into d matrix, and in continuous discrete time system, the first transfer function is equal to c into zi minus g inverse h into d. Okay, any doubt? Any doubt?
No, sir.
Just wait.